You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Cloud Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Domain name system security is a critical concern in cloud networking. DNS is a foundational service that translates domain names into IP addresses, making it essential for connecting to cloud-hosted services, virtual machines, APIs, and external endpoints. However, standard DNS traffic is inherently vulnerable to spoofing, hijacking, and eavesdropping. DNS security mechanisms such as DNSSEC, DNS over HTTPS, and DNS over TLS are designed to address these threats. Cloud Plus includes DNS security within networking and access control domains, and candidates are expected to recognize how to deploy and secure DNS infrastructure in the cloud. Without DNS protection, attackers can intercept or alter DNS responses, redirecting users to malicious destinations, stealing credentials, or causing service disruption. Malicious actors can also use DNS as a covert channel to exfiltrate data or perform command and control operations. Unencrypted DNS queries can reveal sensitive domain lookups, especially in enterprise or hybrid cloud environments. Cloud Plus exam scenarios often describe symptoms of DNS tampering or interception and test a candidate's understanding of appropriate mitigation techniques. DNS in the cloud functions just as it does in traditional infrastructure, but with added scalability and flexibility. Cloud providers offer native DNS services that allow users to create, manage, and resolve DNS zones. These services support a range of record types including A, CNAME, TXT, and MX. DNS zones may be public, resolving names over the Internet, or private, used for internal service resolution within a virtual network. Candidates may be asked about DNS resolution behavior or how to configure zones within a cloud-native environment. DNSSEC, or Domain Name System Security Extensions, protects DNS integrity by allowing clients to verify that responses come from legitimate sources. It achieves this by adding digital signatures to DNS records. These signatures are created using public key cryptography and validated by clients during the lookup process. DNSSEC defends against attacks such as cache poisoning and spoofing. Cloud Plus includes DNSSEC as a tested concept, especially when validating DNS security at the zone level. DNSSEC relies on a hierarchy of keys and a chain of trust that extends from the root zone to the specific domain. Each zone uses two types of keys: the zone signing key, ZSK, and the key signing key, KSK. These keys work together to sign DNS records and authenticate the keys themselves. Clients validate the trust chain during each query. Understanding the structure and function of these keys is essential, and the exam may include questions about DNSSEC deployment or verification failure. DNS over HTTPS, or DoH, enhances DNS privacy by encrypting queries using the HTTPS protocol. Instead of sending DNS requests in plain text, DoH tunnels them through encrypted HTTP sessions. This prevents interception by network observers and blocks some forms of censorship or surveillance. DoH is widely supported by modern browsers and is easy to deploy at the client level. The Cloud Plus certification may test the difference between encrypted DNS transport methods and scenarios where DoH improves privacy without requiring DNSSEC. DNS over TLS, or DoT, achieves similar encryption goals by wrapping DNS queries in transport layer security. DoT uses a dedicated port, typically TCP 853, and is commonly deployed in managed systems where DNS traffic is filtered through approved resolvers. While DoH integrates easily into browser environments, DoT provides more control at the network level. The exam may require candidates to compare DoH and DoT and select the more appropriate protocol for a given architecture or compliance model. Understanding the differences between DoH and DoT is critical. DoH is preferred in end-user environments where applications need to enforce privacy independently. DoT is often chosen in enterprise environments with dedicated infrastructure for monitoring and control. Candidates should know that DoH integrates seamlessly with content delivery and browser-based environments, while DoT is typically part of a system-level DNS strategy. Cloud Plus may include questions on deployment trade-offs and performance implications between these methods. DNS security threats include spoofing, hijacking, reflection and amplification attacks, and DNS tunneling. Spoofing involves forging DNS responses to mislead clients. Hijacking redirects users to malicious sites. Reflection and amplification attacks exploit DNS to magnify DDoS attacks. DNS tunneling encodes other data within DNS traffic to bypass firewalls. Mitigation techniques include deploying DNSSEC, rate-limiting requests, hardening resolvers, and using ACLs. Cloud Plus may describe symptoms such as unusual DNS volume or redirect behavior and ask candidates to identify the underlying threat. DNS logging and monitoring provide vital visibility into cloud network activity. DNS logs can reveal sudden spikes in query failures, traffic to unusual domains, or abusive usage patterns that may indicate DDoS attacks or malware. Cloud-native DNS services often integrate with logging platforms and security information and event management (CM) systems. Cloud Plus candidates must understand how to monitor DNS activity and recognize the signs of a DNS-related security event or misconfiguration. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. In hybrid environments that span both cloud and on-premises systems, DNS must be secured consistently across all segments. A common strategy is split-horizon DNS, which serves different responses depending on the source of the query. Internal users get internal IPs and names, while external queries receive public-facing addresses. This separation ensures privacy, supports segmentation, and prevents data leakage. Cloud Plus may ask how to secure DNS in a hybrid model, or when split-horizon DNS is the preferred design. DNS policy enforcement adds another layer of control to DNS security. Using allow lists, block lists, and content filtering, organizations can define which domains users are allowed to query. DNS firewalls apply these rules in real time, preventing access to known malicious domains or command and control systems. These controls help stop data exfiltration attempts and phishing redirections. The exam may ask which policy enforcement method blocks outbound requests to unauthorized domains, or how DNS filtering helps enforce compliance. Cloud identity systems and policy engines can integrate with DNS to enforce context-aware restrictions. DNS queries may be allowed or blocked based on user role, device type, or session context. This allows security teams to tie DNS behavior directly to IAM policies, enabling access that changes dynamically with identity posture. Cloud Plus may describe a scenario where a low-privilege user accesses a restricted app, and candidates must identify how DNS-based identity controls can enforce proper boundaries. DNS services must be highly available. Because DNS is often the first step in any network interaction, its failure can lead to cascading outages. To avoid this, organizations deploy redundant resolvers, secondary zones, and globally distributed DNS infrastructures. Failover systems ensure that queries continue to resolve, even if a primary system fails. Cloud Plus may present scenarios where a DNS outage affects access to services and ask which redundancy measure would have prevented downtime. Public and private DNS zones serve different purposes in cloud networks. Public zones map external domains, such as company websites, while private zones resolve internal service names like virtual machine host names or container endpoints. Both require distinct configuration, access policies, and monitoring strategies. The exam may ask candidates to identify which type of DNS zone should be used in a particular cloud deployment, or how to prevent accidental exposure of private records. Maintaining DNS record integrity is another vital practice. DNS records should be treated as critical infrastructure components, with updates going through formal change management and approval. Unauthorized changes can result in service redirection or domain hijacking. All record updates must be logged, and alerts should be generated for unusual changes. The exam may ask what led to a suspicious record appearing in a DNS zone and which control was missing to prevent it. Cloud-managed DNS services offer several advantages. Providers such as AWS Route 53, Azure DNS, and Google Cloud DNS offer features like automated failover, integrated logging, and support for DNSSEC and DoH. These services simplify configuration, reduce manual errors, and improve security posture through consistent policy enforcement. Candidates should know which capabilities are built into these platforms and how they help protect DNS infrastructure in dynamic cloud environments. Client devices must also be configured to use secure resolvers. This may involve enforcing resolver settings at the operating system level or configuring cloud endpoints to restrict outbound DNS traffic to trusted sources. Without proper enforcement, devices may use unauthorized or unsecured resolvers, bypassing enterprise controls. Cloud Plus may include scenarios involving DNS bypass and ask what client configuration would prevent unsecured lookups from occurring in the first place. Encryption key management is essential for DNSSEC to function correctly. The keys used to sign zones must be protected against unauthorized access, rotated regularly, and stored in secure environments. Automation tools can handle DNSSEC signing and key lifecycle tasks, ensuring ongoing integrity and trust without disrupting service. The exam may present a scenario where expired signing keys lead to resolution failures and require candidates to determine how better lifecycle management would prevent the issue. In summary, DNS security is about far more than just name resolution. It encompasses data integrity, privacy, monitoring, and policy enforcement. Technologies like DNSSEC, DNS over HTTPS, and DNS over TLS ensure that users connect to the right services securely and privately. The Cloud Plus certification expects candidates to understand not just how DNS works, but how to secure it in hybrid, scalable, and multi-tenant environments through layered, protocol-aware controls. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.